All right, good morning, everybody. And today we're talking about the changes that occur after death. So that means we're going to be talking about what the different manners of death are, the causes of death. It's going to be a little gruesome. So if you are super easily grossed out, we're just talking about it. I don't have a lot of real pictures in today's notes because I don't want to freak you out at 8 a.m. here. So let's take a look. So our goals that we looked at in our know and need to know table yesterday was that you can explain how the body changes after death, and you can ask questions about the manner, cause, and mechanism of death for a specific case. So like you could ask questions that would get us to the answer if we were solving a case. We do have quite a few vocabulary terms, but a lot of them overlap. So death, the different manners of death, I think you'll pick up pretty quickly. The mortises are going to be something that some people like trick up a little bit, so we'll have to work on that. And then some of these like lividity and rigidity are like other words for these, but I added them to the term list after in years past people got a little confused. So we'll be seeing these throughout our presentation. Okay, so our introduction. Also, my expectation when you're taking notes is that you don't have to write every word because you have access to the PowerPoint either through a video or if I publish like the actual PowerPoint for you. So what I would hope that you would do is just write down like the highlights. Okay, so like if I say death is defined as the end of life, or we can say cessation, which means the end. That would be something that I would write down. Death is not like an exact moment when we're talking about death of all of the cells in a body because they don't all die at the same time. And I think that that's a little bit weird to like process as a concept. So we think of like they are determined dead on the scene or in a hospital when the heart or the brain stops, right? But it is something that's still debated because like you can have a situation where someone's brain activity has stopped, but the rest of their body is still working. We also talk about resuscitation where you can get someone's heart beating again. There's a debate on whether they were considered dead while it wasn't or not. It is very important, though, that we are able to determine the time that has taken place between death and when the body was discovered, because this allows us to establish a timeline for the crime and place different suspects there, explain the circumstances that this person may have died, whether it was natural or a not natural cause. Does that make sense? No. Okay. So the manners of death would be what? What do you think the different manners of death could be? We could have natural, accidental, suicidal, homicidal, and then there's this undetermined one. Undetermined is one of those things that you do not want to see on a death certificate. This is not good. If you can't determine the cause of death, or I'm sorry, the manner of death, then it's going to be problematic for the family if they have life insurance. It's going to be problematic for the investigators who need to be able to determine if they're going to pursue this case or not. Obviously, if it's a natural death, then we're not going to have an autopsy most of the time. If you are, like a 60-year-old man dying of a heart attack, you're probably not going to have an autopsy. If something is accidental and they're questioning if this is a real accident or if something else was afoot, they might do an autopsy. They would also do an autopsy if it's a very young person or a child, or if it is a homicide. So suicides, usually it's only if it's suspicious would they do an autopsy. So if there was no cause for questioning that, they would just go on with their ruling of what the manner of death was. So homicide is an automatic autopsy. And so homicide is another word for murder. Suicide was by self. Accident could be like a car, a natural like event. Trying to think of other examples of accidental. Overdose can be considered accidental if it was not done with intent of suicide, if that makes sense. So heart attack could be our natural example, cancer, and so on. All right, so the manner of death has to be one of these 5 things, but our cause and our mechanism of death are going to have a lot more options. And so I think a lot of the TV shows lead us to think that the cause of death would be homicide, but really the cause of death is the reason someone dies, not how, but the reason someone dies. So you could say that the cause of death that led to a person's death was hanging. If we had hanging as the cause of death, then the mechanism is what was the specific change in the body that brought about the end of life. So cessation again means end. The thing that happens in the body if we are looking at hanging, it would be asphyxiation, right? So the lack of oxygen to the brain would stop brain activity, and that would be the mechanism of death. What about if we had stabbing as the cause of death? So if we had, I gotta quit doing that. All right. If we had stabbing as the cause of death, then we would have the loss of blood would be our mechanism. So it's 2 things. One is like what actually was the reason that they died. And then the mechanism is what is that specific change in the body that brought about the end of life. So when you get a death certificate, it would be issued by the state, would have the victim's name, where they died, some demographic information, and it would also give the cause and sometimes the mechanism of death. So if it was strangulation or drowning, again, it's that asphyxiation or the lack of oxygen that would cause the death. If it was a natural death, they could say it was heart attack. And they could say if it was like some complication of cancer or another natural illness. Okay, so when like someone dies, it's not all that singular event. There is first like that stoppage of the heart or brain. But then there is the death of all of the cells in your body. So your body is made up of many, many cells of many different types. I mean, you have skin cells, brain cells, muscle cells, everything. These cells go through a process called autolysis. So auto means self, and lysis means like to cut. So if you have a like if you get your wisdom teeth taken out and you get an abscess in your mouth where you got your teeth taken out, that abscess has to be lysed, or you like slice, like I think slice, and it allows us to let out the infection and treat that in your mouth. But in this case, the self-cutting word, so autolysis, is talking about cell self-destruction. So what happens is when you were in biology and you learned about the parts of the cell, do you remember the lysosomes? Okay, so lysosomes are like the digestive system of a cell. So those are going to get out. into the cytoplasm, and they are going to start to digest all of the other cell parts. It's going to explain the leakage of decomposition. So like on all those crime shows, when you see a decomposed body and there's a lot of fluid, it's because your cells are actually breaking down and releasing their fluids through this autolysis process. And for those of you here in class, I'm going to give you the PowerPoint, so if you don't get every word, don't freak out. Okay, so here we have our first of the mortises. So algor mortis is used to figure out, this again is the post-mortem interval. So the post-mortem interval is after death time. Like we're trying to figure out how long ago that person died. So algor mortis can help us determine the time of death very accurately if it has occurred in the past 24 hours. And it has not been subject to any unusual heat loss conditions. So unusual heat loss conditions would be like very cold environments. So if they've been put outside during the winter, or if they died outside during the winter, if they were in some sort of refrigeration, those things would make using algor mortis not as accurate. Because algor mortis is talking about the cooling of the body. So while you are alive, your body is producing a lot of heat. Your body's actually spending probably more energy on keeping you from overheating than any other body process. So everything that your cells are doing, all of the work that they're doing releases heat, and your body has to make sure that you don't cook yourself. It's very, very important that you maintain, remember homeostasis from biology, which is keeping that normal body temperature. Sometimes our body increases its temperature on purpose, like when you have a fever, that's designed to help fight off infection by making it not a good environment for those invading pathogens. But it's very important that you stay in that window. And so because your body keeps that normal temperature, we're able to measure the change that occurs after death. So for the first 12 hours after death, especially like this is based on your body being in a room that's room temperature, so around 70 degrees Fahrenheit, your body is going to cool at a rate of 1.4 degrees Fahrenheit per hour. So every hour, your body is decreasing by 1.4 degrees Fahrenheit. So considering that the body starts out around that 98.6 degrees Fahrenheit mark, and that's 37 degrees Celsius, you're dropping down this much per hour. But after the first 12 hours, the rate of cooling slows down. It's not cooling off as fast because now the body's temperature is closer to the room temperature. So it's not losing heat as quickly. And so now we're only losing about 0.7 degrees Fahrenheit per hour until the body becomes the same temperature as the surrounding. And so that is, if we remember, equilibrium. We're looking to be equal with the surroundings. Now, these rates are an estimate and may vary based on the conditions around it. So some conditions that could make it vary is like the temperature of the room, or like the humidity and the different environmental conditions. So algor mortis is talking about that cooling of the body. Our next mortis is about the pooling of the body blood at the lowest point. So livor mortis is the pooling of the body's blood in the lowest points of the body. So if a body was found lying on its back like this, you have this shading right here. That is where all the blood settles down at that lowest point. If there was something under the body, like if you had some sort of object here that was raising this part, the blood would not be pooled there. And it would be able to show you if the body was laying on top of something. This also helps investigators know if the body has been moved after death, because if it lays here for at least 2 hours, you're going to start seeing that pooling. And then after 8 hours, the pooling is permanent, which means no matter where you move that body after the first 8 hours, that coloration is going to stay there. If there was massive blood loss, then there would be less of this pooling because there'd be less blood that was able to settle there. It's a bluish purple, like it's a very dark coloring. It looks kind of like bruising. And in the next few days, I will show you some real pictures, but I want to make sure everybody can get the notes without graphic pictures, and then you can choose whether you want to see actual pictures or not. All right, the next slide does have a picture of a deceased animal. It's not super graphic, but if you are concerned, fast forward through this part. And it is talking about, on the next slide, rigor mortis. So this is the one that most people recognize. Like when we talk about rigor mortis, everybody's like, oh, I know what that is. And so rigor mortis is talking about that stiffening of the muscles after death. So it usually becomes apparent within the first 2 hours after death. The stiffness starts in the smaller muscle groups, and then it moves to the larger muscle groups, which means it starts in the face, and then it goes, I want to erase that. Why is it not letting me erase? To the rest of the body. So after 12 hours, the body is going to be in its most rigid state. So it's like the completely stiffened body. But then after it reaches that maximum point, it's going to start decreasing. So it's going to follow the same thing from the face to the rest of the body. It's going to start relaxing. Why would the rigor start relaxing? It has to do with what we learned at the very beginning of this PowerPoint with the autolysis. So the muscles are made up of cells. Those cells are going to go through that autolysis or self-destruction, and that's going to break them down over time. Once the muscle breaks down, it's starting to dissolve. It's no longer able to stay in that stiffened state. So it will relax as it decomposes. So if you are one of my biomed kids, you talked about, or in anatomy and physiology, you talked about myosin and actin. This is what it looks like inside a muscle fiber. And so actin and myosin work together to relax and contract muscles. So usually, like when you're flexing your muscles, this is what the contracted state looks like. Oops, go back. This is what the contracted state looks like, but right here, when you are in rigor, it is contracting beyond that normal state. It is contracting to the full extent that a muscle can't. They are pulled so tight, it is not a natural amount of contraction that you could replicate on your body right now. Does that make sense? and they are locked until those muscle fibers actually decompose. All right, so let's look at some of the timeline stuff here. So from 2 to 6 hours after death, rigor has begun. The body is stiffening and it moves through the body. So it starts in the small muscles, like in the face, and progresses to the larger muscle groups, like in the chest, arms, and legs. At 12 hours, that rigor is complete. So peak rigor is exhibited, the entire body would be rigid. Back in like it was early photography. They have a picture of a body balanced on two stools. And I mean, it's like the stiff as a board kind of image there. Between 15 and 36 hours, there's a slow loss of rigor. So rigor would be uneven. So those smaller muscles, like in the face, would start to relax. And then later, the larger muscle groups would start to relax. That makes sense because in smaller muscle groups, they would decompose faster because there's fewer cells that would have to be digested. And in the larger muscle groups, there's more that has to actually break down before it would relax. During the 36 to 48 hours after death, rigor would be gone. The muscles would be relaxed. But there are some variables that can make rigor go beyond that normal window. So a lot of these things are going to repeat themselves where we're talking about what factors influence our conditions, affect our like different mortises. And I have those for you on the next slide. So temperature, if it is cold, it will slow down rigor, so it prevents it or inhibits it. If it's warm, it'll make rigor go faster. So the hotter the environment, the faster rigor will set and move through the process. So you as an investigator have to be aware of the conditions that the body was found in. Now, activity before death, this is talking about like exercise. If you are doing something very physical right before you die, it is going to accelerate rigor. And that's because your muscles were using up oxygen and they built up that lactic acid, like the feel the burn exercise thing. And that is also going to increase your body temperature and make that rigor go through its phases faster. If you were asleep, like completely relaxed before your death, it would slow the rigor down because your muscles have as much oxygen as possible, which would make rigor move more slowly. There is also a connection between body mass. So a more obese person would have slower rigor because fat is able to store oxygen, and a thinner person who has less body fat would lose oxygen more quickly. All right, so then we're going to talk about autopsy. So autopsy is a medical examination to determine the cause and manner of death. It's a clinical autopsy, could be done for medical research, and that is just for study purposes, and they're not looking at foul play. But forensics autopsies are performed when foul play is suspected. And so any suspected homicides would have a forensic autopsy. If someone very young and without health conditions were to pass away, they might have more of the it would be between these two. Like they would be looking for, was there something suspicious or was there an underlying health condition that they didn't know about? All autopsies are going to have an external examination and an internal examination. And the external exam is going to be looking for different evidences that could be on the body, collecting different specimens. And the internal examination is going to look what happened in the body that led to this person's death. One thing that they'll look at during an autopsy is our stomach and intestinal contents. So within the 2 to 6 hours, the stomach empties all of its contents into the small intestines. Within 12 more hours, the food leaves the small intestine, and within 24 hours, the wastes are released through the rectum. So what that means is if you can look at the stomach contents and there's food in there, you could place what their last meal was. And also, depending on if it's in the stomach, the small, or the large intestines, you can figure out how long ago they ate that meal before they died. So it can allow you to figure out that time frame a little bit more. One thing is, whenever we are working in our next unit on actually calculating time of death, I will give you these numbers in tables to use. Like, you're not going to have to memorize it. You'll get to where some of it you know off the top of your head, but I'm not expecting you to know every single number. Like, that's way too much. All right, so stages of decomposition. This is gross to talk about. There are no pictures at this point, but we are talking about from the initial, like right after death moment, all the way to skeletal remains. So fresh would be that the corpse appears normal on the outside, but is starting to decompose from the actions of those bacteria and autolysis. So bacteria are also part of this process. And it's when, like, I'm trying to think of how to not make this super gross. So your body has lots of bacteria naturally right now. Your body is keeping those bacteria in check, like they're not actively trying to destroy you. But after death, the bacteria would continue to grow because they are alive and your cells are not anymore. So it would aid in that decomposition process. Your body temperature, like we said, is dropping after death because you're no longer producing heat. And usually the room would be cooler than your body, so it's cooling down. This is also the stage where insects would begin to lay eggs. So if you're outside, there would be different insects compared to if you were inside. Bloating is our second stage. So this would be, there's the odor of the decaying flesh is present. The corpse would appear swollen. The skin looks marbled in color and may split open from collected gases, resulting in fluid seepage. Insect activity is increasing. So this is like what you see a lot happening on the side of the road with roadkill. When you see them kind of ballooned up, that's that bloating stage. The active decay is a very strong odor. It's discolored. There's rupturing. I know on some of our, more dramatized crime shows, like in Bones, they have like the exploding bodies where they're trying to get the conditions to where the gases are building up in the abdomen, and they do have to escape somehow. Once they have escaped, they are going to kind of collapse while the fluids continue to escape. So most of the body mass would be lost to insect activity at this time. Once we get to advanced decay, the flesh is gone. It's fewer insects are remaining because now there's not a lot for them to eat and it's drying out. And then our final stage is when we're just looking at mostly bones remaining. So I have like a rule of thumb kind of thing for estimating how long someone has been deceased based on decomposition. So if the body still feels warm and is not in rigor mortis, or this is flaccid, so that means like it's not all tightened up, they've been dead less than 3 hours. If the body's warm, but rigor has started to set in, we're looking at 3 to 8 hours. If the body is cold and has that rigor mortis, then we're looking at that 8 to 36 hours. But if the body is cold and it has lost rigor, we've been looking at more than 36 hours. Okay, so on this slide, I have 9 different scenarios. And I want you to try and guess if you think that this was within 2 days, after 4 days, or within 6 to 10 days. So all you have to do on your paper is write A, B, or C for numbers 1 through 9. So I want to give you a minute to try that. right, if you are at home and you are not done answering these 9, please pause your video right now. We're going to go ahead and talk about what answers you should have had. So for number 1, fluids beginning to leak from the body openings as cell membranes rupture, that would be within 6 to 10 days. So that's pretty far in the process. The discoloration of the face for number 2 would be within 2 days. The skin sloughs off would be 6 to 10 days. The skin blistering is the after 4 days. So that's B. Green and purplish staining from blood decomposition. That's like that livor mortis. That's going to happen in the first 2 days. The corpse bloating is going to be the 6 to 10 days. Eyeballs and other tissues liquefying would be 6 to 10 days. The abdomen swelling would be 4 days. And the marbled appearance of the skin would happen within 2 days. So you are going to submit your answers to this thing, even though I gave you the right answers, just as your proof of doing this assignment on Canvas. And now we're going to talk very quickly about the insects. So we can use insect activity to help us figure out time of death. So we have specific scientists called forensic entomologists who are responsible for analyzing the insects that are found on a body. So your crime scene technicians and police officers can help with the collection process, but they would be able to determine how long that body has been in that environment. So within minutes of a death, there are certain insects that arrive and lay their eggs on the warm body. For example, blowflies would do that. They are going to look for the openings of the body is where they're going to be laying their eggs first. So if you look at some like the body farm videos and stuff, that's where you'll notice more activity in the early stages. So as the corpse decomposes, there are different kinds of insects that will start to arrive. And so by looking at which insects are on the body and what stage of their life cycle they're in, we can estimate how long the body has been there. So again, I will give you tables that have this information. You don't have to memorize it. So I'm going to go quickly through these next slides that talk about the blowfly life cycle. So within that first 8 hours after death, blowfly eggs can be found in the moist, warm areas of a corpse. Within 20 hours, those eggs have moved on to their first stage out of 3 different larva stages. And so they're about this look. This is a cartoon illustration of a first instar larva. By the 4th or 5th day, those larvae have moved on to their 3rd stage. So they're more mature, they've changed in color. After 8 to 12 days, the larva is migrating away from where they were initially placed to a drier place. And 18 to 24 days after death, they are now in early pupa. So they're not able to move. They change from that light brown to a dark brown. And then after 21 to 24 days after death, you would start to see the pupa cases splitting open and the adult flies emerging. So you would see adult flies at the very beginning because those are the individuals laying the eggs on the corpse. But then you really wouldn't see adults again until that 21 to 24 days later when they've actually emerged. So these insect life cycles provide scientists with a benchmark to estimate the time of death. So we have very specific studies about how the temperature that the body was found in and the location would affect the speed of the insects moving through these phases. We'll actually do some of those calculations. You do not have to mess with blowfly larvae though, like there'll be no real bugs. We'll just talk about the different stages there and calculate time of death from that. It cannot really give us the exact time of death because of those environmental conditions, but it can help give us a close estimate, and it can confirm some of the other things that we're using for time of death. So if we're looking at the cooling of the body says they've been dead for this long, And we have the insect activity agrees with that. That's good. The more of these time of death pieces that we can have come to the same conclusion, the more confident we can be that we have the accurate postmortem interval. So this unit, we're talking about all of the definitions of these things and what they are, and making sure we're comfortable with this vocabulary. Well, as comfortable as you can be talking about this gross stuff. And then in the next unit, you're going to actually be calculating the time of death from these things. So we're going to be continuing to use these terms, so it's important that you understand them right now. If you have any questions, make sure you send me a message. But that is it for today's recording.